What if you could manage a complex list of records, like a boutique's entire inventory, without writing a single explicit loop? Stay with me to discover how Elixir's Enum module makes transforming your data effortless, readable, and highly scalable. Howdy, I'm Kevin. In these videos, I explore AI tools to help us learn. I start with getting Copilot to add documentation and provide a starting solution. We'll evaluate Copilot's code and explore alternate approaches. I'll include segments of NotebookLM's explainer videos or quizzes to introduce concepts. Let's see how NotebookLM introduces the Enum module.
Okay, so what do we have to do? We've got to sort everything by price, track down items we forgot to price, update a bunch of product names, and then get a total count of all our stock. Sounds like a ton of work, right? Well, not really, because we have a secret weapon.
And that secret weapon is Elixir's built-in toolkit called the Enum module. Seriously, think of this thing as your data Swiss Army knife. We are going to use it to get this entire inventory problem solved, and fast.
I mean, Enum is basically your go-to multi-tool for data. It's absolutely packed with functions for sorting, filtering, changing, and summarizing pretty much any collection of data you throw at it. It's powerful, super efficient, and it's the perfect solution for our boutique problem.
All right, so here's Copilot's completed solution for us to critique. So for sort by price, we're given a list of inventory items. They're maps like these here in the example documentation. So we're going to take that list of inventory. For each item in there, we're going to get the price. So that's this key here. And we're going to sort by that. It's a perfectly good answer. What you're probably going to see more often is the use of the anonymous shortcut for this anonymous function here. This is the capture operator. This is in place of the item variable name here. It's the first one, that's the and1. And then we're going to get the price. And we know that if the price key doesn't exist, then we'll get nil. Turns out nil is bigger than any number, so if you were actually dealing with nil, maybe you would want to have a default number to use there. Now this is different than if the key didn't, you could also have gone map.get the price, and if the key doesn't exist, return 0. This one will cover both the key missing and the key being there, but the value being nil. And then there's one other syntax that you might very well see when solving this problem, which would be to use the dot notation. If the map has atoms for keys, and you know that the key is going to be there, you can say item.price. This will raise an error if any of these maps should come in without a price key. So I think based on this exercise, we're not concerned with missing values or nil values, and you're more likely to see the anonymous shorthand than you are the full anonymous function here. So I think the best answer is this one. One way to think of the Enum module's functions are a team of specialized personal assistants for your data. Instead of manually giving instructions for each single item, you hand the entire list to the assistant responsible for sorting by price, or another for filtering to find missing prices, and yet another for calculating the total quantity. They handle the iteration, you just define the goal. For the with missing price task, we need to find all the items that meet a specific condition. So we want to filter the list based on the items that meet that condition. So transforming is going to allow you to do things like change names, change the data, but get a whole list back. Enum all, there are a few functions in there that will let you test the condition, like do all of these things have a price, or do all of them have a name? We're not looking for a Boolean answer here. Reducing is supposed to take the list and, let's say, counts up the quantities. So we're going to take a whole list to get back a number. That's not what we're after filtering. Or with missing price, I think Copilot's answer is pretty decent. We're going to filter our list of inventory items based on whether each item, if the price value is nil. I think what you'll find is that it's slightly more idiomatic Elixir to use the isNil function instead of doing the comparison to the nil value. Purpose being that you can use this, say, in guards, where you can't with the double equal sign. I think you'll also see that this is typically written using the access square brackets instead of map.get. Further, I think this would be written again with the shorthand like so. To provide a counter, this is filtering. So this is keep the things where the price is nil. You could alternatively say, let's reject the items where there is a price. And this is a little bit cleaner on the clause here because we're saying if it's got a price, it could be 0. So long as it's not nil, it's got a price. And so we're going to reject the items with a price, which says we're going to keep the things that don't. So this is a mix and match between where do you want to put your negative statement. Do you want to say, is it nil and keep it, or do you want to reject the things with it? I believe this exercise, the filter statement, is more in line with what they're asking. We all use AI to simplify complex topics, but AI isn't always correct. When you use an LLM to learn about Elixir, how do you verify its explanation? Share your AI blind spot check in the comments below.
Let's say your boutique is doing a little rebranding. You decide t-shirt sounds a bit dated and T is way cooler. You need to make this change across your entire inventory, but you are definitely not going to do it one by one. So how do you do that? Well, the perfect tool for this is Enum.map. This is probably one of the most useful functions in the whole toolkit. It's like a magical copy machine. It walks through every single item on your list, applies whatever change you tell it to, and then hands you a brand new list with all the updates. It is the ultimate tool for bulk changes.
Copilot's implementation of update names is decent enough. It takes the inventory, that's the list of our items, and for each item in there, we're going to calculate an updated name by getting the name with string replace the old word for the new word. Then we put that new value into a map. Now this is of course a new map, and that gets put into the list of new items. Reasonably well enough. You could do the string replace right in line here. That would help a little. Another way that's often used is to introduce a private function to do the update name bit. And then what you can say here is that we're just going to call update name on each item. So then the mapping is simpler. And then what we do here is on the update name, so long as the thing has a name, we're going to capture that as the old name. Here we're simply doing the string replace with the old word and the new word, putting the new name in and returning that. If it didn't have a name, which they all do, but here's a case where if it didn't have a name, we just return the item. So this is a little bit safer in the long run, but not necessary really for this exercise. But then this update names is perhaps a little cleaner. I don't think the exercise is looking for this particular solution where they're going to call it out, so I'm going to revert it back to what Copilot had for our solution.
Okay, so here's a cool under the hood detail. You might be wondering, wait a minute, I thought Enum was for lists. How does it work on a map, like the one on the left? Well, this is the clever part. When you give Enum a map, it secretly treats it as a list of tuples. A tuple is just a little container for a couple of items, like you see on the right. By turning the map into a list of these key value pairs, Enum can use all its list handling magic on maps too. Pretty smart, huh?
In increased quantity, you must transform the values of the quantity by size map and return a new map. The documentation mentions there's a specific function that works like Enum.into, but is dedicated to always returning a new map. So Enum.into will allow you to return, to create a new map or a keyword list, for example. So what they're asking you to recognize here is that Map.new communicates very clearly that we're creating a new map, so they want you to choose C. For increased quantity, Copilot provided a solution. It's not at all like the exercise is asking for. This is the case where they were asking us to use the Map.new function to create the increased quantities. So what we need to do here is given an item, so now we don't have the list, we just have a single item. They want us to look at the quantity by size and increment all the values here. So we want to update or create a new map for the quantity by size. So what Copilot did was it took that quantity by size, it did a map of each size by increasing the count, and then they used Enum.into to create a new map and then assign that to the quantity by size. So this works, right? And it's very similar to what we're going to do. We're just going to do it differently. This has the disadvantage of it creates a whole nother list and then it does the transform. What we want to do is we want to use Map.new so that we know we're doing this map instead of a keyword or anything else. It will take the quantity by size map. Then we have this same function, the size, quantity, and increase the count. But this has the advantage of creating the map without creating that list as an intermediate byproduct.
All right, time for the final challenge. We need a hard number. How many red shirts do we actually have in stock across small, medium, large, and extra large? We need to turn that map of sizes and quantities into one single number. And for a job like this, you need Enum.reduce. If you think of map as transforming things one for one, reduce is all about boiling an entire collection down, collapsing it into one single value. It's like taking a list of ingredients and reducing it into a sauce. We're going to take our list of sizes and reduce it to a total stock count. So how does it actually work? It's pretty cool. We start with an initial value, in our case 0. This is often called the accumulator, but it's easier to just think of it as our running total. As reduce goes through each size, it grabs the quantity and adds it to our running total. So it starts at 0, adds the 3 smalls to get 3, then it takes that new total, 3, adds the 6 mediums to get 9, and just keeps going, carrying that running total forward till every size is counted.
And here in total quantity, Copilot again provided a viable solution, but it didn't do it like the instructions want, nor did it do it in the most efficient way we could do it. What Copilot did was it took the quantity by size map, and for each one of them, here's the key, the size, and the value, the quantity, it just pulled the quantity. So at the end of this, it would have a whole list of quantities, just the integers, and then it summed them up. Did it get the right answer? It did. Is it the most efficient way and the way they want us to use for the exercise? No. What the exercise wants us to use is the Enum.reduce function. So we're going to take the key value pairs from the quantity by size, and we're going to accumulate them. Our starting point for the accumulator is a count of 0. And then so for each size quantity pair in this map, take our accumulator and add the quantity. So this is going to go 3, and then we're going to add 6 more, and then we're going to add 5, and then we're going to add 2. So Copilot got technically a correct answer. The test would pass, but it's not what the exercise was looking for, and nor is it the most efficient way to do it.
So if you remember one thing, make it this. Elixir's Enum module isn't just a bunch of random tools. It gives you a core set of verbs, actions you can take on your data. You can sort it to create order. You can filter it to find what you need. You can map it to transform everything. And you can reduce it to get summaries. These 4 actions alone can solve an unbelievable number of data problems you face every day.
I've shown you how to reduce your inventory to a single total quantity. But now I need you to reduce the number of people who haven't subscribed. Hit the like and subscribe buttons. Enumerate the playlist to build your Elixir expertise one powerful function at a time. See you there.